It's my pleasure to introduce Henry Pack from Elastic. Henry Pack is a solutions architect for Elastic, which is based out of Los Angeles. With a focus on data analytics and integration, Henry has been helping enterprises across a wide range of verticals more easily access and derive meaningful information from their data. He'll be presenting a talk titled Anomaly Detection in Time Series Data using the Elastic Stack. Please join me in welcoming Henry.
Thank you. Just like a quick clarification, I live in Los Angeles. Elastic, the US headquarters is actually based on Mountain View, and the worldwide headquarters is actually based in Amsterdam. So if any of you guys came from that far, welcome. If not, thank you everyone for coming here. Hope you guys have had a great day so far. So today, we'll be talking about how you can do, we have a new machine learning plugin that just came out, and it came from a lot of work that we did acquiring a company called Prelert about last year. And they've been around for about 7 years, and they have this really neat algorithm that can build a model off data that comes in real time for time series data. So we'll go into it real quick. So typically in your data, you might want to look for anomalies for different types of use cases, right? And here I have 3 up here. One is IT operational analytics, one is security analytics, and one is business analytics. And we can just kind of dive into operational analytics. And some examples of anomalies that you might want to try to find within your operational analytics is, let's say you got a spike in the middle of the night somewhere and you want to get a load on it, right? And here's some other examples that you might want to look into. For security analytics, you might want to know maybe some sort of IP or a subset of IPs, are exhibiting some sort of strange behavior, right? And even for like IoT or business analytics, you might have a bunch of telemetry data feeding into Elasticsearch, and you want to see when you get certain irregular patterns or things that that just might you might want to look into, right, for further investigation. So what a lot of people try to do is they build these really nice graphs in Kibana, and they try to figure out what might be an anomaly. Like for some of you guys out there, I'm sure you guys look at dashboards all day, and when you see something like this, how can you really detect what an anomaly is? And this is the big data conference, right? So as the data keeps going and going, it's going to get even harder and harder to detect these things, right? And even doing like static analysis is pretty difficult. So let's look at this, and you see a regular pattern, and everything looks okay, but how would you set your static thresholds, right? Do you want to kind of alert off things up there or below? So trying to create these static rules can sometimes lead to a lot of false positives and things like that. Or it doesn't really have meaning. It's just like you're kind of eyeing it, right? So that's where this XPack machine learning plugin comes in. It creates a model based on the data that's coming in, your time series data that's coming in, and it can look through a historical data set, or it can do it in real time. So it is an unsupervised approach. You don't have to necessarily provide it a training data set. Of course, providing a historical data set does give it some time to learn a model and to create that model for you, but it's not required. So as I already mentioned, it's an unsupervised technique, and it evolves as more data keeps coming in, and it actually adjusts to the data that keeps coming in. And also, there's a thing about influencers, and we'll talk about that in a minute in the demo. But essentially what it is that you can actually specify that the algorithm keep track of certain influencers that might be affecting the anomaly. So there are different types of anomalies that you can try to detect with this algorithm right now. So the first thing is looking at your time series and trying to find anomalous points within that time series data. You can also look for outliers in the population, so things that might be significantly different than a general population. And you can also look for rare and unusual events inside inside different categories of events. So the demo is going to look at more the time series stuff, but there's just a couple of other things to keep in mind, which we'll briefly talk over in a minute. So the time series for the single feature detection, we have a single feature that we're charting over time, and we want to know what's anomalous about it, right? And then you might have things that you want to split the data across. So if this was a single graph, representing all the countries, it might not be very meaningful. But here now you're breaking it down by country, so now it can be a bit more meaningful, and you can detect anomalies with better precision, right? And now for the outliers in a population, so the algorithm trying to detect what might be common features within the population and group those population documents together. And then when you have a document that kind of deviates greatly from that population, you can also alert on that. So the example like this is like which IP is not like all the others in the way they perform or in the way they act. And it's just another slide just kind of re-emphasizing that point. So it creates this profile and then anything outside of those bounds. So it's like a multi-feature, multi-dimensional shape that gets generated across a lot of features. And then if anything goes beyond that scope, then you can get alerted on that. And for those of you who have like a lot of logs that are doing log analytics with the elk stack, you can also see if certain log patterns are deviate greatly, or you have some unusual occurrences occurring, unusual occurrences happening in your data, and the application can also, the machine learning plugin can also look for things like that. But I know you guys are probably sick of me talking so much, so we'll just actually kind of go directly into. I don't know why it's not up there, but maybe I need to stop the slideshow. So how many people here are familiar with Elastic Stack? Does everyone pretty much know what Elasticsearch is? Okay, good. So you've probably seen Kibana. This is Kibana. This is the first page that you go into. We call it this Discover panel. And what it does is it allows you to quickly look at your data sets and kind of get an idea of what your data looks like. So here we have a very simple data set, which I call server metrics here. And we can kind of see the pattern over time, how many actually documents we have over time. And you can kind of look at the sample data, sample of the data. So it just has, the number of actually we'll just make it easy. It has the host name. It has an application name that's running on that host. It has the average response time, the total number of connections, and then the connections that were accepted and denied.
Can you zoom in a little bit?
Oh, sure.
Thank you.
So here you can see how the data looks like. And if I were to do your typical, chart it over time, you can see here that, I have a total graph here depicting all the connections over time, some of them, and then on the bottom graph, I have the average response times over time split down by applications, right? And even if I were to drill in here, it'd be really hard for me to detect what might be an anomaly and what might not be, right? So that's where machine learning comes in. And here we'll create a job real quick. We'll first go with a single metric job. And here I'll pick the index I want to look at, which was a server metric one. We'll pick an aggregation, and what this is what sort of metric, what do I want to compare it against, right? So for us, because it is an average response time, let's look at the mean in general. But you can do things like high mean, and what that means is like you only want to get the anomaly to detect if it's over a certain value, right? Or low mean is like if it's below the average mean value, right?
Henry?
Yes.
Is this a service provided by Kibana, or is this something that you got?
So this is part of the XPack plugin, which is our commercial plugin.
Gotcha.
So it's an offering that runs on top of Elasticsearch, on top of the open source stack. So you could just, you'd have to install it both on Kibana and Elasticsearch.
Okay, thank you.
And we'll pick the field, we'll do the average response time. You can pick a bucket span, which is essentially, the name implies. You pick the actual number of buckets, the amount of time that you want to put in each bucket. And then just hit play. And so we get this error saying no results found because we have no real-time data coming in. So we use a full historical data set. And this is what the data looks like. We'll give it a name. we'll do our analysis.
There's
sorry.
a character in the left bracket. And their name.
Sorry, thank you. Okay, so now you can see the algorithm going through the data. This is a single metric data, so it runs it pretty fast, and we can look at the results. So here I have this sliding time window here. I can go to the beginning of the data here. If I reduce it a little bit, you can see that the algorithm is learning as it's going through the data. And at first, it has no idea about the data. So there are no error bounds. It has no idea what to alert on or try to create a model off of. But as it goes through, you can kind of see this cloud being formed here, kind of creating these error bounds. And then as we keep going through the data, you can see that there's this pretty large cloud here of the error bounds trying to model the data. But then about the third day, you can see that it detects the periodicity in the data, and it significantly reduces those error bounds. And then, to the point where, after a few days, you can actually start detecting anomalies, and we can drill into one of these anomalies here. And what it provides you is a normalized score from 0 to 100 here. And you can see here that the actual value was 2.41 when the typical value should have been 2.33. And it assigns a probability score based on the model that it generated. Yes.
What is this called? Like, what's the algorithm called, or what?
So it is a proprietary algorithm that the Preler team, the company that we acquired about a year ago, that they've been developing and enhancing for the past 7 years. And they've won a couple of competitions, in fact, some open data competitions. So it's a pretty mature algorithm, and they keep improving on it as it goes. But it is specifically for time series data, or you have to have a pattern in your data, right? If it's just random data, it's not going to be able to find anomalies because it doesn't.
So what do you guys call it? I mean, the algorithm. I mean, it doesn't have a name even within the company.
I mean, we could call it the machine learning algorithm.
Oh, I mean, okay. I guess if I fired this up and I said I want to run whatever this guy ran,
sure.
What do I call it? Like, is it called anything?
No, this is only a single algorithm, right? So right now, this is a specific for just doing unsupervised detection, anomaly detection. It is proprietary, so that's why we don't give it out. But it has a lot of, it's not just a single algorithm, obviously, right? It has, PCA components, Bayesian probabilities, a lot of different things, exponential decay, things like that.
When it detects an outlier, does it have a way of expressing what it is that is anomalous about it? I see a probability score, but will it say it's so many standard deviations out of the mean, or what? I guess kind of following on the previous gentleman's question is, okay, it's an anomaly, but what does that really mean? What is anomalous about it? How does it tell us, and what does the probability score mean? Sure,
so that's what the probability score is, just based off the model that it generates, right? So the chance of it happening, according to the model, of that value showing up is the score right here, right? So actually, let me go to the next example that might kind of help to kind of show how this could be more useful in when you're logging analytics use cases. Any other questions about this though? So now we can actually go into a multi-metric job, and we use the same data set, but this time we'll split the data out by host, which would probably make more sense, right? So kind of get an idea of maybe what hosts, like if the anomalies are different by host. So we'll go back to the average response time, and we'll also kind of just see how many connections were denied just for fun, so you can do it. We'll do the means for both of them, and we'll split the data by host. And now here's the key fields that we talk about as being influencers. So you can pick additional features that you think might affect the anomaly. So the algorithm will keep track of this and kind of show things that might be pointing to what might have caused anomaly when it does this analysis. So here we'll call it multi-metric. And then we'll run this one. This one might take a little bit longer because it is only on a laptop and it's going through a lot of number crunching. So just give it a second. Any questions in the meantime?
Is that pack free to use now?
So there's a 30-day free trial that you can use and download. And there are certain parts of XPack that are free, but unfortunately this one is not one of them. So here now we can view the results here. And now you get an overall anomaly timeline viewer here that kind of shows you, overall throughout the whole data set, what anomalies were detected over time. And then it breaks it down for you by server here. And we can drill into one of these, and it kind of gives you the same kind of picture as before that we saw for the single metric. But we can now dive into one of these anomalies. And now we see the same kind of information, the actual value, the typical value, probability score assigned to it. But now we have these influenced by section here that kind of hints to you what might have caused this anomaly. And so this would be great for things like root cause analysis, right? Here already you kind of have an idea of maybe what might have caused like a cascading thing to happen. But as now, when you dive deep into the anomaly, you can see that most likely it was caused by application 4 that causes this anomaly to happen. Any questions?
Is that probability score, is that the p-value? Like, is it the chances of error is that? Or
So it's the chance of, so remember, it's not really showing you an error. It's really just showing you that based on the model, the fact that value like this shows up at that time is anomalous, right? So it's more like an anomaly score. Like probably that's something with that value happening.
So if the probability is lower, you're more confident that that's an anomaly?
Typically, yes. So what you would do is you would tie this in with like the alerting plugin, and you would use probably a normalized score and alert off of that, right? So you don't have to go in and set these static thresholds, right? So you might have time series data, and you have but let's say you do have a good idea of what static thresholds you should set, right? But you don't have to go in there and do it yourself, right? So you just have the model, the algorithm compute the model for you, and then just alert off certain thresholds that you want to be alerted on, right? Based off the probability score.
When we say like measuring the anomaly from type of a model, like what kind of model are we talking? Like a Riemann model or a regression model?
So the model that gets generated here, so it's a combination of different algorithms, right? So that's the proprietary algorithm I was talking about earlier.
Okay.
And I mean, we can provide you additional, if you're interested in the math, we have some white papers out that kind of tell you like which components are involved.
And I think my question is kind of asked too, but are there any set of distributions that they're basing these kind of range of probability in the model? Is there a subset or is this kind of a range of distributions you're using?
I don't know about distributions, but it does try to, like feature detection, like reducing dimensionality, things like that. And I know it's heavily using Bayes probably, Bayes and numbers.
How would you compare that to the Facebook profit library, which tells us time series anomaly forecasting?
I'm not too familiar with Facebook.
Library profit.
So it's not a library. So one thing to keep note that this is not a library. The plugin does say machine learning, so eventually we want to release things that allow you to do more supervised type of learning. But for right now, it's mostly unsupervised, and yeah, you can't like really pick which sort of components that you want to enhance or decrease. There are some things that you can tweak though. So if we go back into creating a job, you can also create an advanced job. And this kind of gives you the most flexibility to do whatever you want. So you can pick any number of indices here, right? And the types within those indices. You can even set which timestamp field that you want to look at. Go next. Now you can pick the different detectors that you want. And you can also have multiple detectors, right? So you can pick what kind of functions you want to look at. So you can have like a rare, add that. But you can also go in and, because it's still running on top of Elasticsearch, so you don't actually really need anything different, right? You don't need additional, you can use additional hardware because the machine learning algorithm kind of requires more CPU, so you might want to have dedicated node types, but that's not necessarily required. But you can actually go in and actually specify the type of query that you want to run. So you can actually give it any sort of query, any subset of a query that you want to run, that the machine learning algorithm will only perform its analysis on that subset of data. And if that wasn't enough, you can actually go in and actually tweak the JSON directly if you really want to do that.
So I think somebody asked this, what made you prefer like unsupervised versus supervised learning?
Excuse me?
What made you prefer like unsupervised machine learning methods versus supervised machine learning methods?
So for this particular one, so I think the people who started the Preler company, they wanted something easy for people who are not data scientists to get up and running quickly, right? To do analysis on things where they don't have to know, which library I have to use or which algorithm I have to use, right? They want to be able to just go in, I have this time series data that I want to get alerted on. I don't want to have to worry about setting static thresholds. How can I do that? In a way that actually shows me value, right? Where I'm not going to be woken up in the middle of the night for a false positive, right? Or less chance of that happening.
Question. So,
yes.
Just to follow up on that. So I get the sense of, say I'm like an IT operations manager, and I want to get a sense of a couple of things. First of all, jobs in my data processing platform and my data warehouse are running long or failing. And like you said, the rule-based alerting or whatever on data volumes and other stuff is too inflexible, it breaks a lot. And maybe I'm also tasked with monitoring operational metrics, like we're not delivering enough packages fast or whatever. But I want to know in near real time if this is happening. I can see right now you're clicking a job to run it. Can you set this up so that I can get this sort of near real time, kind of rerun the job every minute, or?
Absolutely. So that's what this is actually designed for. So that this job is constantly running and taking data in as it comes in.
Okay.
And looking at the data, seeing if it's anomalous or not, and contributing to the model as data keeps coming in. So that's actually what this is actually designed to do.
Okay, so when you clicked it to run it once off, that I could actually set the job to become a continuous run mode.
Yes,
basically.
absolutely.
Okay.
And that's typically what most people would do.
Okay.
This is just because I don't have real-time data streaming into my laptop right now.
I'm just curious if you, since it's proprietary, the regressions it's doing, how does it behave when you feed it random data, like white noise?
So it's not going to work well for things like that.
Will it catch a lot of things or see nothing?
It'll probably see nothing, right? I won't think anything's honest, because it can't really create a model, right? Because everything's kind of like.
What's the kind of like periodicity that it can catch? Because so when you're talking about like operational, like it could be you're talking about latency, milliseconds, microseconds. But when you're talking about say on the scale of like marketing or product analytics, it could be days, months, possibly some cycles might be years. Really depend on historical. But even if you're trying to do like say a sales cycle, it could be monthly periodicity for looking at the sales funnel that Elasticsearch is capturing on on the web traffic, but then you're trying to capture behavior patterns, anomalous behavior patterns. Like, is there any kind of periodicity kind of sweet spot basically?
So it really depends on how much historical data that's where you learn from, right?
Mm-hmm.
So if you don't have enough for it to learn some periodicity, it's not going to learn it, right? So something like Black Friday is a good example, right? Yeah, it'd be hard for it to detect like Black Friday not being an anomaly because most of the time it's not, right? It's when you see this huge Black Friday peaks. So you might have to do some sort of special analysis for something like that.
Right. So like a rule of thumb, how many periods you want to have? If you have could either acquire or create a historic data set, how many periods do you suggest that be there to capture?
That's a good question. For typical like daily patterns or weekly patterns, it's been like 4 or 5 maybe that I've personally seen periodically.
Yeah.
But who knows with yearly, right? Yearly mixed with daily and things like that, or monthly.
It's compound.
Yes. Any other questions?
So what about the spatial patterns? Like you've shown that you can do temporal. There is space like space.
So it is built for time series data, but if you can somehow trick it to make it think that it's time series, maybe it could work. I haven't tried it myself personally. Yes.
Piggyback off the gentleman in front said, can you guys detect long-term and short-term anomalies?
I mean, it just treats everything the same, right? So it might have aspects where it kind of, detects different types of periodicity, but it won't like necessarily know that one thing is a short-term error and one thing is a long-term error. As the data comes in, it's going to, quickly identify, based off a predicted value, how far is it from that particular target. Yes. In the back.
All of that, the jobs. Can you have multiple jobs running, or is it, what's the architecture? What's one job per node, or how do you scale it if you want to run simultaneous?
Sure. And that's a heavily, it depends question, of course, because it depends on the hardware specs that you have for that node and things like that, and how much data is coming in at one time. But you can typically have a few jobs running on a single level node. And we always recommend having at least 2 ML nodes because, just for fault tolerance purposes. But probably like 4 or 5 jobs should handle it relatively easily with decent hardware. And I'm talking about maybe like 8 core CPU. It doesn't require that much memory.
Is it just detecting a variation in a single time sequence, or is it a multivariate regression that will say this went up when this one went down? Is it actually being causal in, say, MVC relationship? Is it looking at each time series independently, or is it looking for correlations between 2?
So you can specify those parameters, right? That's kind of what the
So it can do
multimetric. So that's kind of what the second one did, right? The multimetric, you can actually split those by type, or you can actually even, modify the query to only look at certain subsets of data. It's really however you want to do it, right?
Yeah, but I wasn't clear if it was doing looking for variations in several data sets, or if it is actually comparing them and looking for a correlation between 2.
So you can have it going across all the data set, the whole data set, and also you can have it going between like individual data sets, right? So when you split the data set up, it's going to look through the individual ones, right?
Can it say normally when this goes up, but this time that didn't happen? This one went up and the other one didn't? Is it actually doing a correlation between 2 time series?
No, I don't think it's doing the correlation, right?
It's just looking at multiple sets independent.
Yes. And then you can do the correlation between when you have that the anomaly detector looking at everything. And if you were to go back to the multi-metric here, you can kind of do some correlation based off this chart, right? If you kind of had an idea of what I actually look at. But if you had a lot of hosts, right, you can kind of see like which ones are having anomalies, and kind of see a pattern, right? And then looking at the influencers, maybe get a better idea of trying to get into root cause analysis.
But that's being left to the human to see.
Yes.
Yeah. And the question of multimetric, whether you're trying to find correlations between different streams, that's really important to make sure you have the answer to, because if they're doing a good job with that, they would want people to know.
So that's kind of what the influencer kind of plays a
role. I'm curious
role.
why the job is called multimetric, because I would not, I assumed.
Oh, no, so I did have.
I assume it's correlated as opposed to several individual metrics.
Yeah, your load shoots up because you have a lot of jobs in the queue. You expect that to happen. You want to be warned when the load shoots up, even though you don't have a lot of jobs in the queue. 2 separate time series.
Yes. So this was called multi-metric because I actually picked multiple metrics. So it actually combined 2 features. So here it does. If you look at the job config, it looks at both the mean response time and the mean number of connections that got denied. So that's why this one was termed multi-metric.
Okay, so that's not something you chose. It's not an option. It's just what you named it.
Yes. No. It is an option. So here, going back, if I wanted to create a new job again, you can actually pick different fields for it to look at. So it's a combination of those 2 fields that cause the anomaly, right? So it's a combination of those features.
But it's still not correlating between them. It would simply require there to be an anomaly in both for it to consider it an anomaly.
Yes. I mean, the correlation kind of exists in the period, right? I mean, the fact that it's their period, it's detecting a period of information, so if they have correlated periods and they have correlated anomalies, I think it's kind of built into the fact they're trying to capture it. It's trying to capture the period and the anomaly at the same time. So I mean, it's not directly; it's not like an indirect, kind of like implied correlation.
You're sort of getting that.
I don't know. I'm wondering if it's a different option, whether they're actually trying to detect anomalies with correlation. That's my.
Well, that's kind of what these influencer fields are again.
Give me a bunch of single metric jobs.
Yeah, I mean that's a good question.
So what was that? Could you repeat that question?
I'm just, you know, we can just Google and like look it up and see what they claim that they're doing, but.
Yeah, the white papers, you can put the white paper up there.
The fact that they created a separate option makes me wonder about whether it's truly separated.
What's truly separated?
The individual streams, whether you have multi, whether it's not trying to get information from each of the streams simultaneously.
So that's what okay. So looking at this data set again, we're splitting things up over a specific field, right? But we can also assign it multi-fields. So these are like kind of like the features, right? The features that you want the model to learn against, or to, yes, exactly, to learn against, right? To process. And then what this splitting data is actually, you were saying, but I wanted to split data across a certain field, right? So that's going to be done separately. So for each host, it'll be done separately. But it's still a combination of these two features for each field, for each host. I'm sorry.
Okay.
Does that help? Any other questions?
The root cause analysis.
Oh, last one, sorry.
Is that available in the automated alerts? Like, is there further details as to why something happened available in the alerts, or just there's an alert?
No, so there is just the text of anomalous event and what caused that anomalous event by these influencer fields. So then you can start doing your root cause analysis, right? So you can dive in and go into. So eventually we're going to try to improve that UI a bit so that you can actually go straight into your Kibana dashboard and have a link that takes you to that filter or whatever that you created to really dive in and try to get the information that you want. Well, thank you everyone for your time.